Okay, 2.8 is on page 236 of your book. So let's open up to page 236. We're talking about solving inequalities in one variable. So this is basically, we're solving an inequality. So instead of up till now, we had like x cubed minus x squared plus 2x minus 3, and we solved this. Okay, this is what we've been solving. We've been doing polynomials, and we're solving these equations like this. So what this is now is that we're going to go ahead and solve this. Okay, not equal to 0, but greater than 0. One is greater than 0, or things of that nature. One is greater than 8, or stuff like that, right? So we're going to do inequalities in one variable. So it's basically kind of the same stuff we've been doing, but we're going to add a slight twist here. And in the end, you're going to have to do one more step to figure out the answer. Okay? So let's do example, jump right into example number 1 and see what we can figure out. Example number 1, let's go ahead and says let f of x equals 2, f of x is equal to x plus 3, x squared plus 1, x minus 4 squared. Determine the real number values of x that cause f of x to be 0, positive, and negative. Okay, so let's go ahead and graph this. Okay, first of all, what degree polynomial is this? Anybody? Brady, what degree polynomial is this?
I'm not sure. Don't
X squared, you get an x squared from here too, right? So yes. The highest one is going to be x squared times x squared plus times x. So it's to be x to the 5th, right?
Oh, yeah.
So it's going to be a polynomial to the 5th degree, right? 5th degree. So when you're trying to graph this, since it's an odd number and it's going to be positive, right? The leading coefficient of this polynomial is 1, so it's positive. So it's going to start up here, right? This is going to give us a root of 4, a solution of 4. This is going to give us a solution of negative 3. Okay. This is going to give us no solution, right? Because this is always going to be greater than 0, right? So I'm going to start here. What is this called? This little thing here indicates what? This is a, what do we call this? Hunter.
An exponent.
Okay, it's an exponent, right? But as far as solutions go, there was a special word that we called this. Remember we had this word called multiplicity? This is a multiplicity, right? So you're gonna have double roots here. So it's gonna come down here and it's gonna go, and since it's an even number multiplicity, it's gonna come out like that, right? And then in the end, it's gonna go all the way down here because it's an odd number polynomial, x to the 5th, right? So it's gonna come up from here, it's gonna go like that. And in between here, it's gonna do a little dip. It's gonna come down, oh, okay. It's gonna do a little dip, and it's gonna come down like this. So this is how I'm gonna draw the polynomial. Okay, everybody understand how the steps that I went through to get that? Okay, so it's gonna be a negative 3, right? Negative 3 comes right here, and then the 4 is over here, but it's a multiplicity of 2. Since it's an even number, it does not penetrate. Remember, when it's an odd number, it penetrates. When it's an even number, it does not penetrate, goes right back up, and does a little dip, and this is what it's gonna look like, okay? So the question is, so A, when is it equal to 0? A says when is it equal to 0? So this guy, f of x, is equal to 0 at x is equal to negative 3 and 4, right? B, when is it positive? Is that what the answer question was? When is it positive? Positive meaning this. Okay, so it's positive where? Where is it greater than 0? It's greater than 0 from here to here, right? So from -3 to 4, notice it is the open bracket, and then 4 or greater, right? And then also 4 or greater, okay? Another way to put this would be x is greater than -3, but x cannot be 4, right? C would be, now in C, they want to know when is it negative? When is it negative? So it's negative where? Down here. That's the only time that it's negative, right? So it's going to be negative when, it's going to be negative when it is that, right? So it's whether on this side, it's negative, right? Y is negative. The Y part is negative, right? Down here. Okay. So in other words, when we start doing inequalities, you do this, you solve it for 0, find these points, right? So now the extra steps involved in doing an inequality is once you got these points, you have to draw it and then figure the rest out. Okay, so these are the extra steps involved with the inequalities, okay? All right, so that's example number 1. Let's go to example number 2. Example number 2, solving inequality analytically. So solve 2x cubed minus 7 squared minus 10x plus 24. And I'm trying to solve this guy. Again, so I have to solve equal to 0 first, right? So how do I solve this equal to 0? It's basically going to be, and I have to do it algebraically, right? So in order to do it algebraically, I'm going to have to do a what? To find the zeros of this, I would go ahead and do the synthetic division, right? I have to do the synthetic division, right? What are the possibilities here? Since it's the end is 24, my possibilities are 1, 2, 3, 4, 6, 8, 12, 24. And then, since I have a 2 here, I also have to add plus or minus 1/2, plus or minus 1 3/2, right? If I divide this by 2, it just becomes that. If I divide this by 2, it just becomes that. Divide this by 2, it becomes that. Divide this by 2, it becomes that. Okay, so we're all good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 20 different possibilities, right? 20 different possibilities. So what did I tell you to do? If you end up with something like this, what is the way to go? How are you going to find this?
Using a calculator?
Yeah, use the calculator, plot it, and find out what it's supposed to be, right? And then go ahead and do the synthetic division. So if I go ahead and plot this on my calculator, I will find that it looks like 4 is one of the answers. So let's go ahead and use 4 as our first thing in our synthetic division. So we have 2, -7, -10, 24. So the 2 comes down, 4 times 2 is 8. Add together, I get 1. 4 times 1 is 4. Add together, I get -6. 4 times -24. And yes, indeed, we do have a winner. Okay, I have a winner there. Okay, and if I do, so what do I have left? So this basically, I find that this is going to be equal to x minus 4, right? X minus 4 here. And what do I have left? 2x squared plus x minus 6, right? Okay, so from here, I can actually do this factors out. So if I factor this out, I'm going to get x minus 4, and this guy here is 2, 1, 2, 3, plus negative. So plus 4, negative 3, add together, I get plus 1. So it's going to be 2x minus 3, x plus 2. There you go. So I have 0. So if I set this equal to 0, I get x is equal to 4. And I get 3 over 2. And over here, I get negative 2. So these are my 3 roots. Okay. So if I go ahead and I draw that, I get 4, negative 2. Right? These are my roots. I'm going to start from here because I have a positive coefficient. I start here. It goes like that. Okay, and now the actual question was, when is it greater than 0? So when is this greater than 0? When is it greater than 0? It is greater than 0 here and over here. So I'm going to have negative 2 to this, and x is greater than x is greater than 4. So this here is going to be my final answer. Okay? It is greater than 0, so y is greater than 0 from negative 2 to 3 halves and greater than 4. Okay? If I change the question and I ask you this, what would the answer be? When is it less than 0? Less than or equal to 0, right? Less than or equal to 0 would be down here, right? Less than or equal to 0 would be over here and here, right? So it would be x is less than or equal to negative 2, or x is, 2/3 and 4. Did everybody get that? Everybody understand that? How that came about, right? Because this was positive. This was less than or equal to 0 if I had solved that, right? Okay. Now, obviously, the easiest question would be this, right? When it's equal to 0, and then your answer would simply be right here. Okay. So what we've been doing in 2.7 and before this section is we were doing this, and we were only asking you to do this. But now we are going to give you that extra twist, and we're asking for this, and now you have to come up with this. Okay? That's the difference between just solving for zeros and solving an inequality. Okay? Okay, so that's that. All right, example number 2, move on to example number 3. In example number 3, if you look at that, it says solving it graphically, and then all you do is just put it in your calculator and tell me where it's greater than 0. So I'm not going to go over that, really. There's nothing much there. Okay. Let's go to example number 4. Example number 4, it says, solving a polynomial inequality with unusual answers. Okay, so in A, it says, the inequality, so we have f of x is equal to x squared plus 7 and 2x squared plus 1. Okay. And solution of 1 is equal to 0. Well, this guy here is always going to be greater than 0. It's positive. As a matter of fact, it's always going to be greater than 7. The smallest this could be is 7. Over here, the same thing, right? This is always going to be greater than 0 because this guy is always greater than 0. So this guy actually is always going to be greater than 1, right? So this whole thing is always going to be greater than 0. So your answer is basically all reals, right? All reals. Any real number works. Okay. The solution of this guy greater than or equal to 0 is also all reals, right? What about the solution to this guy? What is the solution here? When is this going to happen? When is it going to be equal to 0? Caden, when is it going to be equal to 0?
I'm unsure.
Never, right? Because this is never going to be 0. This is never going to be 0, right? So this would be no solution. Just as this guy would be no solution, just as this guy would be no solutions, right? Okay. All right, let's look at B now. So that was A. Let's look at B. I have G of X is equal to x squared minus 3x plus 3. And I have 2x plus 5 squared. Okay, so let's go ahead and find one is greater than 0. So if I graph this, what do I get? If I graph this, graphs like this, okay, where this 0 here is going to be this guy here, right? -5/2. Okay. So when is it greater than 0? Always going to be greater than 0, except for x equals 5/2, right? Because it can't be 5/2, because if it's 5/2, it is actually 0, right? It's actually 0. So your answer is going to be this, right? Now, if I went like this and included the 0, then everything, right? Then your answer is going to be all reals, right? Because everything is greater than or equal to 0, right? Because everything's greater than or equal to 0 here. Okay. If I asked you this, what would your answer be? When is it less than 0? When is this graph less than 0?
It is not.
Never, right? It's never, correct. Very good job. So it's never going to be less than 0. So you have no solutions here, right? But if I ask you this, what's your answer here? When is it greater than or equal, less than or equal to 0? This is kind of tricky. Your answer is going to be this guy, right? Because at this point, actually, it is 0. And it satisfies this bottom part here, right? So this is going to be your answer if I ask you that question. Okay. So as you can see, there is a bit of thinking that has to be done when you're solving inequalities at the end, okay? You go through everything, all those hardships that we talked about on the prior sections to get to find it. And in the end, you have to do one more thing. Okay, like I keep on saying, right? Okay, all right, that's good. Now let's talk about rational inequalities. Rational inequalities, again, it throws you a little bit of a wrench at the very end, okay? So let's go ahead and jump into example number 5. And example number 5, rational inequalities. Let R of x is equal to 2x plus 1 divided by x plus 3x minus 1. Okay, so A, let's find out when it's 0. When is R of x equal to 0? When is it equal to 0? It's going to be equal to 0 when this guy is equal to 0, right? X is equal to -1/2. B. When is it undefined? When is it undefined? It is undefined when these guys are 0, right? These guys on the bottom are not allowed to be 0. So it's undefined at x equals to -3 and x equals to 1. Okay. C. Where is C? When is it positive? Okay, when is it positive? So for this guy to be positive, so now what needs to happen, right? What needs to happen is if I have to go ahead and look at the positivity, whether it's positive or negative, of each of these 3 things, right? So in other words, I'm looking for the positive. So this is going to be positive when because this is a pretty important part, right? This is going to be positive when this is going to be positive, right? Okay, so when this is positive, this is what we're trying to find, right? But we also have to keep in mind that x cannot be this. Okay, all right? Okay, so when is this positive? Well, I have 3 roots, right? I have 1, -3, and I have -1/2 here. That's going to look like this. Okay, so when is it positive? It's positive here and here. So it's going to be -3, -1/2. X is greater than 1. Okay, again, this is not easy. Okay, this is kind of new. Okay, this is going to be positive when this guy is going to be positive, and this guy is going to be positive after I draw the polynomial. This is when it's going to be positive. Okay, so that would be C. D is when is it negative? So this is going to be negative when this guy is going to be negative. So negative would be, this section over here would be negative, this section here would be negative. So it looks like x is less than 3 and -1/2 x is 1. Okay, one thing that I kind of did not mention, but I kind of assumed here is that you have to always check for this, right? It can't be this. Okay, so, and that's not going to be -3, and that's the 1 is not included, so we're okay here. Okay, all right. Example number 5. Let's do one more. Example number 6, and then we'll take a break after that. So let's do example number 6. Example number 6, solving by combining fractions. So 5x plus 3 plus 3x minus 1, and I want this to be less than 0. So obviously I'm going to do the common denominator. Minus 1. 5x minus 1 plus 3x plus 3. Okay, this is the same as 5x plus 3x is going to be 8x. I'm going to get 8x. I have -5 plus 9, so it's going to be plus 4. I'm trying to solve for this. Actually, I'm going to pull the 4 out here. So it's going to be 4, 2x plus 1. Okay, the 4, I can divide both sides by 4. So the 4 goes away. So I end up with this. I end up with 2x plus 1, x plus 3, x minus 1, less than 0, and becomes the same problem that we solved in example number 5. So I had to go through, in example number 6, if I give you this question, you have to go through this and then to come to this and then say, well, for this to be less than 0, this is the same as x plus 3, x minus 1 being less than 0. Then I'm going to do the same thing I did before over here. And I'm going to have, what was it? I have 1, negative 1/2, and I have negative 3 less than 0. So let's go ahead and redo that. So it's going to be like that. Less than 0, so it's going to be here and here. So x is less than 1/3, negative 1/2 x 1. Okay? All right. So a simple looping equation here gets quite involved. Okay? All right? All right. Okay, we're going to stop here for the first half.